So on this page, we're getting into that classifying quadrilaterals, and we do this by finding slopes and lengths. We've got to figure out whether it's just a parallelogram, if it's a rectangle, rhombus. It can be more than one of these, so we want to be careful. We also don't want to rely on a graph because, as you can see here, this goes from like -7 to 7 in each direction, but it's much wider than it is tall. So we want to rely on the data. So let's go ahead and graph this. This is 0, 0 for A. And then B is at 6, 3, so we're going to go over 6 and we're going to go up 3, so there's B. C is at 4, 7, so we're going to go over 4 and up 7, so C's right there. And then D is at -2, 4, so back 2 and up 4, so D is right there. So we'll go ahead and connect those. So this is, I mean, it certainly looks like a parallelogram of some sort, but what we want to do is we want to find the slopes. Now, if you've got a graph, you can go ahead and find the slopes by just looking at it. I am going to go ahead and find the slope on a couple of these. So I'm going to find the slope from A to B, and I'm going to do that using the slope formula. So remember, this was the point 6, 3, and this was the point 0, 0. So I'm going to do y2 minus y1, so I'm going to do 3 minus 0, over x2 minus x1. So this is going to be 3 over 6, so we end up with 1/2. So the slope on AB is 1/2. And then I'll do C and B, so BC if we want to call it that, and this is 4, 7. Okay, so if I do the slope of BC, that's going to be y2 minus y1, so that's going to be 7 minus 3. Whoops, I'm thinking ahead to the answer. 7 minus 3. And then I'm going to do 4 minus 6. So we get a 4 over -2, so we end up with -2. So the slope for BC is -2. Now again, if you don't have a graph, you're stuck doing this. If you do have a graph, it is possible to just kind of count these. So we could go through and we could say, look, to go from here to here, I'm going to rise 3 and I'm going to run 6. So a rise of 3 and a run of 6, we'd have a slope of 1/2. So let me back off from that. And then on this one right here, again, it's normally best to go from left to right. So we would go down 4 and over 2. So a rise of -4 and a run of 2. That would give us a slope of -2. So we'd be in good shape there. Now, if you do have a graph, it's totally okay for you to go through and say, look, I'm going to rise 3 and we're going to run 6. So that would be 3 over 6. So from C to D or DC, this is going to be 3 on the top, 6 on the bottom, so that's going to be 1/2. And then we can do the same thing down here. I think you can kind of see that this is going to work out to be the same slope as that. So we end up with a slope of -2 on this one. So we've got a slope of -2 there. And now we'll move on to the lengths. Now, lengths, we do want you to use the distance formula on that. So I'm going to slide down here just a little bit so we've got a little bit of room here. So what we're going to do is we're going to go through and we're going to find the distance formula. So I'm going to write D of AB. Okay, so we want to find the distance, and the distance on that one is going to be the difference. So it's going to be x2 minus x1, all of that sort of stuff. Now I've got the points here. I've also got them right up here, and those are the ones that I'm going to use. So for AB, I'm going to do this. x2 minus x1, so this is going to be 6 minus 0, quantity squared. And then y2 minus y1, right here. So this is going to be 3 minus 0, quantity squared. So this is going to be the square root of, this is 6 squared plus 3 squared. So that's going to be 36 plus 9. 36 plus 9. So we end up with the square root of 45. And I'm going to write that down exactly. So exactly, this would be a 9 and a 5. So this is going to be 3 radical 5. So for AB, we're going to write 3 radical 5, and I'm also going to give a little approximation for this. So we'll grab the calculator really quickly. And again, just double checking here, 45, we get that answer right there, so 6.708. 3 square root of 5. Same answer right there. So again, to the nearest hundredth, this is either going to be 70 or 71. So this is 6.71. Now I'm going to do BC here. So the distance from B to C. So again, we're going to do, let me erase these right here. I'm going to do x2 minus x1. So we'll line those up right there. 4 minus 6, quantity squared. And then we'll do y2 minus y1. So that's 7 minus 3, 7 minus 3, quantity squared. So this is going to give me, let's see what we get here. We get a negative 2, better have those parentheses on there, and then plus, this is going to be 4 quantities squared. So let's see, negative 2 squared, that would be positive 4. And then this is going to be, let's see, 4 squared is 16. So we get radical 20. And that is 4 times 5, so we get 2 radical 5. So this is going to be 2 radical 5 right here, which let's get what that is approximately. So again, pulling up the calculator here, again, double checking, square root of 20, got that. And let's see, we said 2 square root of 5, and we get the same thing. So this is 4.47, so 4.47. Now, we'd have to show the work for the other two, but it's going to work out the same on each one of these. So this one's going to be for CD. This is going to be 3 radical 5, okay, which is approximately 6.71. And then this one right here, again, 2 radical 5, which is approximately 4.47. Now, what are the sides that are parallel? So the sides that are parallel are AB is parallel with, so we'll use the right symbols here, AB is parallel with CD because they have the same slope. And then these two are parallel because they have the same slope. So I'm going to do BC is parallel to DA. Okay, and I'll go ahead and use the format that they've got there. So perpendicular is a little more interesting because perpendicular, we actually have these guys right here. So those two are perpendicular and those two are perpendicular. So what I'm going to do is I'm going to say perpendicular to AB. So AB is perpendicular to, and then we'll just list the other two. The other two are, and we'll do it this way, we'll do BC, perpendicular to BC, and it's also perpendicular to, they say DA, so we'll stick with DA right there. And then we'll do the other one. We're going to do CD. CD, that one on the top, that one is perpendicular, so it's perpendicular to DA, and it's also perpendicular to BC. So we'll go ahead and write it like that. And then congruent sides are pretty easy. Those are just the ones that are exactly the same length. So we're going to say this. We're going to say that AB is congruent to CD. So AB is congruent to CD. And then we're also going to say that BC is congruent to DA. All right. Now, if that's the case, if we've got the opposite sides, they're the same size, so they're congruent. Okay, they're not all congruent, but these two are the same and those two are the same. Well, it's at the very least it's got to be a parallelogram, and then the fact that we've got right angles here, that means that it's got to be a rectangle. Again, it's not a square and it's not a rhombus because all 4 sides aren't congruent to each other. So I'm going to go ahead and circle rectangle, and it's also a parallelogram. Okay, so we'll slide down here and we'll take a look at the next one. We're going to do this one the same type of way here. So the instructions are the same, and on this one we've got a slightly different graph, so let's see what happens here. So I've got A is at negative 1, 0, so negative 1, 0 on that one. So there's A, negative 1, 0. And then we've got B at 1, 3, so that's over 1 and up 3, so we're right here for B. So 1, 3, and then C is at 4, 1, so we're right here. C is 4, 1, and then D is at 2, negative 2, so we're down here. So D is at 2, negative 2. And I've chosen on this one to go ahead and actually put the coordinates right next to each one of them. So it certainly looks like it's a parallelogram of some sort. In fact, it may be, it might be a rhombus, but we've got to check this out and we've got to make sure. So again, for slopes, because we've got a graph, we can go ahead and just count these. So here's what I'm going to do. For AB, I'm going to count up 3, and then we're going to go over 2. So a rise of 3 and a run of 2. So that's going to be 3 over 2. So let me slide this down so I'm sure I'm on the screen here. So this is going to be 3 over 2. That's going to work out to be the same as it is over here. So this is from D to C, or CD. So this is going to be 3 over 2. And then the other one, we're going to go ahead and draw what that would look like. So let me get rid of the picture here. And then over for BC, we're going to go from here down to here. So we're going to go rise negative 2 and then run 3. So this would be -2 for a rise. Whoops, let me change colors here so this all matches up. So this is going to be -2, and this is going to be 3. So we're going to have -2/3 here, and this is going to be -2/3 for AD or DA as they call it over here. Okay, now let's do the lengths. Now the lengths, because it is a distance and we're practicing using the distance formula, let's go ahead and do this one. So for A to B, so I'm going to put distance from A to B. So this is going to be, again, big square root. So I'm going to find the difference in the x's, and I'm going to square that. Then I'm going to find the differences in the y's and square that. So again, if I didn't have a graph, I'd kind of be stuck over here using these. So I'm going to do the difference between the x's, so x2 minus x1, so 1 minus minus 1, and then 3 minus a 0. So this is going to be a plus, so we end up with, this would be 2 squared, and then this would be 3 squared. So we end up with, let's see, this is a 4 and a 9, so this is the square root of 13. Now the square root of 13 doesn't simplify at all, so the length of this would just be the square root of 13, but then we can get a decimal approximation for that, so we can kind of make some comparisons. So let's see, square root of 13, square root of 13, we'll hit enter. So 3.605, it's either a 60 or a 61, that 5's enough to bump it up. So we're going to do 3.61. And then let's go ahead and do, let's do the next one right here. So let's do from B to C. So I'm going to do the distance from B to C. So that's going to be, again, line these up here. So I'm going to do x2 minus x1. So this is going to be 4 minus 1, quantity squared. And then this is going to be, let's see, what have we got here? 1 minus 3. So 1 minus 3 quantity squared. So this is going to be 3 squared plus, this would be -2 squared. And again, always a good idea to use parentheses, even if they're not absolutely required. So we're going to have a 9, because that's 3 squared, and we're going to have a 4 here. So this one also works out to be radical 13. So from B to C is radical 13. So radical 13 on this one, which again would be approximately 3.61. And again, because of the way we found the slope and stuff like that, and because we have a graph on this one, I'm going to go ahead and let you say, hey, if I know that those have the same slope, I had the right triangles and all that sort of stuff, then let's go ahead and say that CD is going to be the same as AB. So that's going to be radical 13, which is approximately 3.61. And then DA is going to be the same as BC. So this is going to be approximately 3. Whoops, I missed a 1 on there. Okay. All right, now parallel sides. Parallel sides are going to be the ones that have exactly the same slope. So that's going to be AB and it's going to be CD. And we could actually mark this on here so we know that those are parallel. So parallel is going to be AB is parallel to CD. All right. And then the other ones that are parallel are going to be BC is parallel with DA. And again, trying to use proper notation and kind of match everything up here. Perpendicular are the ones that are opposite reciprocals. So let's take a look here. Those are opposite reciprocals, and so are those. So we're going to say that AB is perpendicular to, it's perpendicular to BC. So AB is perpendicular to BC, and it's perpendicular to DA. It's perpendicular over here. So I'm just going to put an and DA, okay? And then the other ones that would work out to be perpendicular are these guys right here. Oops, let me draw this line a little bit better. Okay, so we're going to say that CD is perpendicular to, it's perpendicular to BC. We've got CD is perpendicular to BC, so that's perpendicular angle right there. And it's also perpendicular to DA. So I'm just going to put an and DA right here. Okay, now what are the congruent sides? The congruent sides are going to be the ones that are equal to each other. So that's all of them. So we're going to say AB congruent to, we'll do BC congruent to CD congruent to DA. Okay, and that completes it, and that, gosh, that gives us a really good idea of what's going on here. So if all 4 sides are congruent, it's got to be at the very least a rhombus. But if they're all congruent and they're exactly the same size, then it's got to be a square. So we're going to go ahead and say that this is a square, which is also a rhombus, which is a rectangle, which is a type of parallelogram. So we've classified that quadrilateral there. We're on the last page. Let's take a look at problem number 16. So A is at 12, 0. So we'll go over 12, and then we don't go up or down because the y is 0. So I'm going to put A right there, and I'm going to put the coordinates next to this so it's easier to find those. We don't have to refer back to the problem every time. B is at 8, -4. So 8, -4. Again, checking out the scale right here because notice it's a little bit different on each one. They at least look a little different. So this is going to be B, and that's 8, -4. And then C is at 0, 0. So we'll put C right here. C is 0, 0, and then D is 4, 4. So 4, 4 is going to end up right here. So 4, 4, there we are. Now we'll go ahead and connect these. And again, the scale on each one of these axes, they're stretched a little bit differently. So we're going to have to be a little careful on this one. Let's go ahead and find the slope between A and B. I'm going to go ahead and find this one using the slope formula. So I'm going to do y2 minus y1 over x2 minus x1. So I'm going to do -4 minus 0, y2 minus y1. And then I'm going to do x2, so that's going to be 8 minus 12. So we end up with a -4 on the top and a -4 on the bottom, so the slope there is 1. It is positive, definitely positive here. May not look like 1, but remember this has been kind of stretched vertically and a little bit squished horizontally. So the slope of AB is 1, so I'll go ahead and put that down there. Let's find the slope of BC, so from here to here. So that slope is, let's see, we'll do y2 minus y1. So that's going to be 0 minus -4. And then x2 is 0 minus 8. So we end up with a 4 on the top and a -8 on the bottom. So we end up with -1/2. And that's definitely negative, going down from left to right. So this is -1/2. Now, we'll notice that they appear to be parallel, top and bottom here, and then right and left side here. So let's just go ahead and check C and D. Let's check this by counting. So we would rise 1, 2, 3, 4, and run 1, 2, 3, 4. So that's also going to have a slope of 1. And then let's go from D to A. So that's down 1, 2, 3, 4. And then we go over, if you count those, that would be 8 right there. So that also is going to be -1/2. So we can already look at this and identify some parallel sides. The next thing we want to do is we want to do the side lengths. Again, I'm going to use the distance formula for AB. So I'm going to say distance AB. I guess I could have done slope of AB, and this would have been the slope of BC. So the distance for AB, we're going to do x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So this is going to be x2 minus x1. So this is going to be 8 minus 12 quantity squared plus y2, which is -4, minus y1, which is 0, quantity squared. So we end up with, let's see here, this is going to be a -4 squared. And this is going to be a -4 squared. So this is going to be 16 here and 16 here. So we end up with 16 plus 16. So that's going to be the square root of 32, which if we'll remember is 2 times 16, which is 4 times 4. So here's a pair of 4's right there. So if we simplify this and keep this in radical form, this is going to be 4 radical 2. So that's the distance from A to B. So we'll have 4 radical 2 here. Let's go ahead and get a decimal for that. I've gone ahead and pulled up the calculator, put in 4 radical 2. I get 5.656. So if we go to the nearest hundredth, this is going to be 5.66. So about 5.66. All right, let's find the distance from B to C. So the distance from B to C, big square root here, and then we're going to do x2, which is 0, minus x1. So this is going to be 0 minus 8 quantity squared. And then y2, which is 0, minus y1, which is -4 quantity squared. So we end up with, let's see, this is going to be -8 squared. And this is going to be 4 squared. So we end up with, let's see here, -8 squared is going to be 64. And then 4 squared is going to be 16 again, like we had up above. So this is going to be the square root of 80. So this is 5 times 16, which is again is going to be 4 times 4. So we end up with 4 radical 5. So from b to c is 4 radical 5. And again, we'll throw that in the calculator. We'll pull that up really quickly. And let's see. So we've got 4 square root 5. And we end up with 8.944. That 4 is not enough to bump that up. So it's either going to be 9.4 or 9.5. It's going to stay 9.4. So this is about 8.94 approximately. Now these others for C and D, or for CD and DA, let's just go ahead and count and think about this using the Pythagorean theorem. If this is a right angle right here, we've got a leg right here. Again, we counted this before. This would be 4 and this would be 4. So just like the one down here, we're going to end up with 4 squared plus 4 squared equals the hypotenuse squared. So if we take the square root, we're again going to end up with the square root of 32. So this is going to be 4 radical 2, which again is approximately 5.66. And then dA, let's count this. So this would be down 1, 2, 3, 4, and then over 8. So just like we had before, this is going to be an 8 squared. This is going to be a 4 squared. We're going to end up with radical 80 again. So this is going to be 4 radical 5. So again, that's approximately 8.94. So let's talk about parallel sides. Parallel sides would be the ones with the same slope. So that's going to be side AB is parallel to side CD. And let's see the opposite ones. So this is going to be BC is parallel to DA. All right, let's talk perpendicular sides. These are not opposite reciprocals, so these are not perpendicular. So there are none on this one here. And then let's talk congruent sides. Congruent's pretty easy. It's going to be a repeat of what's up above here, just a different symbol. So side BC is congruent to side CD, and then side BC is congruent to side DA. All right. And then let's think about this for just a second. We've got to classify this quadrilateral here. So it's definitely not a square because the sides are not the same length. So that means it's not going to be a rhombus. There's no way there. And it can't be a rectangle because we don't have any right angles. We don't have any sides that meet perpendicularly. So what that means is we've got a parallelogram on this one. Okay, so that's the last of those type of problems. So let's slide down here and take a look at the last couple here. What we want to find here is we want to find the perimeter and the area for the following polygons. And it says round to the nearest tenth. I suppose we could go to the nearest hundredth if we need to. I'm probably going to write these in exact form anyway. So let's just go ahead and do this one right here. So let's graph this. This is ST is at -1, 4. So back 1 and up 4. So S is right there. T is at 3, 2. So over 3 and up 2. So there's T right there. And then let's see, U is at 1, -2, 1, -2 right there. There's U. And then V is at -3, 0. So V is right here. Now, if we wanted to, we could write down all the coordinates next to them. They are sitting right there, so I'm just going to leave them on this one. And let's go ahead and find the distance between S and T. So from S to T, so the distance from S to T is going to be a big square root. And I'm going to take, let's see, we're going to do x2 minus x1. So this is going to be 3 minus 1, quantity squared. And then y2 minus y1. So this is going to be 2 minus 4, quantity squared. So let's see what we end up with here. This is going to be a plus 1. So this is going to be the square root of 4 squared. And then plus, let's see what we have here. This is a -2, and we're going to square that. So this is, let's see, 4 squared is 16. And -2 squared, if we squared it, ends up being positive. So that's going to be plus 4. So this is the square root of 20. Remember, 20 is going to be 5 times 4, which is a 2 times 2, perfect square right there. So we end up with, let's see, we've got I'm going to write it down here just so we save some space here. This is going to be a 2 radical 5. So from S to T, this is going to be 2 radical 5. This other one here, if we wanted to count that, we go down 2 and over 4, just like we do here. Those are parallel, and they've got the same measurements as far as rise and run, change in X, change in Y, that sort of thing. So that means this is also going to be 2 radical 5. So let's check TU right here. So the distance from T to U, so from T to U, let's do x2 minus x1. So I'm going to do a big square root here. x2 minus x1 is going to be 1 minus 3, square that quantity. and then y2 minus y1, so negative 2, 4, y2 minus the y1, which is a 2. So we have a negative 2 minus 2. So here's what we get. We get negative 2 quantity squared plus, this is going to be negative 4 quantity squared, which on this one, let me put a dotted circle around that one right there. This is going to be 4 plus 16. So again, we end up with radical 20. So what that means is this is also going to be 2 radical 5 and 2 radical 5. Okay, we've got enough information that we can figure out what the perimeter is. So that means we just add all of these together. So if I have 2 radical 5s plus 2 radical 5s plus another 2 radical 5s and another 2 radical 5s, this is going to be 8 radical 5. Another way we could do that is we could say 2 radical 5, and we've got 4 of those. So we can multiply those coefficients together if you want to think of it that way, and we end up with this. So let's figure out what that is approximately. And I think I'll change the instructions on this one. Let's say that's to the nearest hundredth, just like we normally do. So we'll pull this up, and we're going to do 8 radical 5. 8 times the square root of 5. And we end up with 17 point, that's going to be 89. So 17.89. So we've got that part taken care of. Now we need to find the area. Now if you're going to find the area on this, we need to find 2 sides that are perpendicular to each other, or we need to find the height so that we can figure out what the area is by multiplying it by the base. So these two right here, if you take a look here, the slope on this one, and I'm going to change colors on this one, the slope here is down 2 and over 4. So the slope there is negative 1/2. And if we do a slope triangle on this one, we're going to rise 1, 2, 3, 4. So we're going to go up 4 and over 2. So rise over run. So this is going to be 4 over 2. The slope on this one is going to be 2. That means these are perpendicular. So that means we can just multiply the 2 of those together. So here's what we get. We get 2 radical 5 for the base. So 2 radical 5 times 2 radical 5 for the height. And we end up with this. Well, let's see. This is going to be 4 times the square root of 5 times the square root of 5. Well, remember, that's going to be the square root of 25. So 4 times the square root of 25, which is 5. So we have 4 times 5, and we end up with 20 here. So I'm going to go ahead and circle that. Let's just make sure we're clear on that. This is units squared, and this one right here would just be whatever the units are. So whether they're inches or kilometers, or it doesn't make any difference. So it would just be units on this because it's a unit of length, and then units squared on this one right here. So I'm going to switch colors over on this one, and let's go ahead and graph these. So we've got negative 4, 5, so back 4 and up 5. So there's where B is going to be. And then 6, 0. 6, 0 is right here for G. And then H is at 3, negative 6. So 3, negative 6, that's going to be down here. So H is right there. And then L is going to be at negative 7, negative 1. So back 7 and down 1. That's where L is. Now I am going to go ahead and put the labels on these, put the points there. And I'm just going to go backwards here. So whoops, this is going to be 3, negative 6. This one's going to be 6, 0. And then this one's going to be negative 4, 5, if that makes it any easier. So we'll go ahead and connect these. And we kind of notice that as we're doing this, the scale on both of these, this hasn't been stretched at all. 1 unit this direction is about the same as 1 unit in that direction. So this looks pretty good. It looks kind of like a rectangle. And I'm going to do this one a little bit backwards here. Let's just think about what this would look like as far as slopes go, so we can see if we have a right angle here. So we're going to go down 1, 2, 3, 4. And then we double check 1, 2, 3, 4, 5. Actually, we've got to go down 5. So the rise would be negative 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be a rise of negative 5 and a run of 10. So that means the slope on this one's going to be negative 1/2. Let's check this one over here. We would rise 1, 2, 3, 4, 5, 6, and then over 1, 2, 3. So if we did rise over run on this one, 6 over 3 would be 2. That means the 2 of these are perpendicular. That means we're going to be able to use this as the base and this is the height. Or I guess we could do it the other way if you wanted to. So let's go ahead and find, let's find this distance right here. Let's find from G to H. So we'll say distance from G to H. So G to H. And we'll put a big square root here. And we're going to do x2 minus x1. So that's going to be 3 minus 6 quantity squared plus y2 minus y1. That's going to be negative 6 minus 0 quantity squared. So let's see here. This is going to be 3 minus 6. So that's going to be a negative 3, and we're going to square that. And this is going to be plus negative 6, and we're going to square that. So we end up with, this would be negative 3 squared is 9, and negative 6 squared is 36. So we end up with the square root of 45 right here, which is 5 times 9, which of course is 3 times 3. So this distance right here would be, we've got a pair of 3's on the outside and a 5 stuck on the inside. Let's see, let's write that one down. So this is going to be 3 radical 5 from here to here. Okay, now let's find the distance from here to here. Let's do from L to H. So that would be this one. So I'm going to come down here and do L to H. And let's see what we've got on that. So we're going to do x2 minus x1. So that's going to be negative 7 minus x1, which is 3. And we'll square that. And then we've got y2 minus y1. So this is going to be negative 1 minus. Make sure that minus is there. And then we're going to put a minus 6. So here's what we end up with. This is going to be negative 10 quantity squared. And then we've got negative 1 minus minus 6. So that's going to be a plus 6. So that's going to be a 5 squared. So we end up with 100 from that. And we end up with, 25 from this. So we end up with the square root of 125. So that's 5 times 5 times 5. We've got a pair of 5's. We're going to put that on the outside. So 5 radical 5. So this right here is going to be 5 radical 5. So now we can figure out the perimeter, because if we were to count here, let's just double check and make sure like we had before. We'd go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have something that's sloped the same, and it would have, we could draw a triangle for that for the Pythagorean Theorem, or use the distance formula. So we end up with 5 radical 5 on this one, and then 3 radical 5 here. So if we add all of those together, if I have 3 radical 5 plus 5 radical 5, I have 8 radical 5. I'd have another 8 radical 5 between the two of these. So what we end up with is 16 radical 5, and that is approximately, we'll pull up the calculator here. So I guess it would be double that one. So this is going to be 16 times, clear that off, 16 radical 5. And yep, so we double that right there. We get 35.77. We'll go to the nearest hundredth again. So we're going to call that 7/8. So 35.78. So we'll circle that right there. So the last thing we need to find is the area of this rectangle. So we're going to find the base and the height. So we've got a base right here and a height right here. We verified that this is a right angle through the slopes. So you can either say this is the base and that's the height, or this is the base and that's the height. But either way, we're going to end up with something like 5 radical 5 times 3 radical 5. So when we multiply those together, I multiply the 8 and the 5 together, I get a 15. And then I have a radical 5 times a radical 5. When we multiply those together, this would be 15 times radical 25, which is going to end up being 15 times 5, because the square root of 25 is 5. And we could have seen that right here. We're basically squaring the square root of 5. So we end up with 75 here. So I'm going to write 75 units squared. Circle that and we're all set to go. Okay, a really good practice for the test. Make sure you're ready to go and ask questions if you need them. If you need to do the practice test more than once, feel free to do that. Good luck.